Now we're going to use that roadmap to solve a couple of problems briefly. So you did the roadmap on page 100, but now I want you to jump to the page in the slides for the warm-up for today, and you're going to take notes on the following problems in the warm-up slides, and then you'll complete the warm-up on this page. So keep referring back to the Molar roadmap, but you should not be doing any of the following work on the Molar roadmap. So first, what we're going to do is I'm going to say that we have 16 grams of O2. So that's a 6 right there. 16 grams of O2 gas. So since I have grams of O2 gas, and referring back to the Molar roadmap, remember, I can convert that to 3 different quantities. In the roadmap, so I'll sketch just a brief little version of the roadmap right here. Remember, I can go from moles to grams, moles to liters, and moles to particles. And by the way, I know I switched the position of grams and liters, but it doesn't matter. That's just showing you what I'm converting. So if I wanted to convert grams to moles, I could take one step to go from grams to moles right here. If I wanted to go from grams to particles, I'd first go to moles, and then I would go to particles. And then if I want to go grams to liters, I'd go to moles, and then I would go to liters. So I'm going to show you how to convert 16 grams of O2 into each one of those. So let's do step 1 here. So grams to moles. So I start with the number given. So we'll call this, so this is problem number 1. I have 16 grams of O2. Now it's very important to keep chemical and your units here. And this is where we're going to do what's called a conversion factor. We get these conversion factors from the roadmap that I talked about. Now in math, if I had x times y over x, this would simplify where the x's can cancel off, and this would leave me with y. So using that concept is going to be important because we want grams of O2 to cancel off. So we put grams of O2 on bottom, and the first thing we would convert it to, using our roadmap over there, is moles of O2. Now, we know that we're looking at 1 mole of O2 if we go back to a roadmap, but remember for O2, we need to figure out how many grams is O2. So again, if we look at the periodic table for oxygen, we have an 8 up here and a 16. So a lot of people would mistakenly put a 16 here, but that would be wrong. This is O2, so that's an O double bonded to another oxygen atom. And so each oxygen atom, if we had 1 mole of oxygen atoms, each mole would be 16 grams. So this would be 16 plus 16. So the total mass of O2 is equal to 32 grams. So we put a 32 here. So now we do the math. 16 times 1 is 16. And then 16 divided by 32 is 0.5 or 1/2. So 0.5 moles of O2. Okay, now step 2, I'm going to use that to convert to particles. I want to know how many particles of O2 that would be. So now I can start with this number right here as my starting point. So 0.5 moles of O2. Set up my conversion factor. Okay, and this time I want moles of O2 on bottom. And O2 is a molecule, so I'm converting that to molecules of O2. Okay, so 1 mole, and we said that this is Avogadro's number, so I'm going to round it 6.02 to just 6. So 6 times 10 to the 23rd. Now this number, all that is a 6 followed by 23 zeros. Okay, that's 6.02 times 10 to the 23rd. So this is just multiply, so it's 6 times 10 to the 23rd power. Okay, so anyways, we now take this number and we take 6. If we multiply it by 10 to the 23rd, and then we're also multiplying it by this 0.5 over here, then I'll put that out here. So we have 0.5 times 6 times 10 to the 23rd. Well, we could do this math first. So 0.5 times 6 is equal to 3. So that gives us 3 times 10 to the 23rd power. Okay, and that would be our answer. But then we need to include units, so that's 3 times 10 to the 23rd molecules of O2. And that's the answer. Now, step 3. We're going to take that answer, and we're now going to convert it to liters. So we're going to assume, that this is a gas at STP. So O2 is a gas at STP. So again, we're going to go back to moles. So 0.5 moles of O2 times, put moles of O2 on bottom, and on top we're converting it to liters of O2. And we know from our molar roadmap that 1 mole of any gas at STP is equal to 22.4 liters. So now I can do the math, cancel off my units, and so 0.5 times 22.4 is just half of 22.4, which is 11.2 liters of O2 gas. Okay, and now we've just converted 16 grams of oxygen gas into moles, particles, and liters. One last thing I wanted to show you before you start working on the warm-up and then your practice problems is if you were to, let's just take a different example. Let's say I had some math here where I was doing 2 times 6 times 10 to the 23rd power. Well, if we did 2 times 6, that's 12. So this would be 12 times 10 to the 23rd power. Although that is the correct math, that is not scientific notation, so sometimes that would either be marked wrong or that would not be a possible answer option, because usually in science they want you to convert the answer into scientific notation when it's a large number like this. So what we do is we take this 12, there's a decimal right here, but scientific notation says there can only be one number to the left of the decimal, but right now there's 2. So that means we need to move the decimal 1 spot to the left. And so that becomes 1.2 times 10, and it was 23. Because this number got smaller, this number must get bigger, and it's going to get bigger by the amount of times we move that. So 23 plus 1 is 24. So 1.2 times 24 is equal to 12 times 10 to the 23rd power. So that's a skill that you'll need to be able to do when solving these problems. All right, well, get started on the warm-up and then the practice problems, and I will see you guys soon.